We're going to be talking about higher order derivatives, and as a quick summary, it's just taking the derivative more than once. However, before we do that, I want us to recap all the ways in which we can talk about the derivative. Okay, first of all, we have the word derivative. We also know it means instantaneous rate of change, slope of the tangent line. We have what's called the definition of the derivative, which involves the difference quotient. Now this is more of the limit of the slope of the secant lines. All right. This one is basically the same thing. Limit as x approaches c of f of x minus f of c over x minus c. In this case, f of c, x is f of x1. Same for c down here, x for x1. Yes. Now this is the definition of the derivative, which involves the difference quotient more formally. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h, where this is your difference quotient. H is your gap, your horizontal gap. And as that approaches 0, you will end up with the slope of the tangent line. Okay, we also have d dx. And of course, as we said before, this is pronounced f prime of x. Another way to talk about it, y prime, that's the derivative. And then dy dx, which is kind of going to be the focus for the first part of this, or at least the second example. All right, now we're going to talk about higher order derivatives. So like I said before, it's basically just taking the derivative more than once. Okay, the first derivative, f prime of x, is just f prime. Pretty simple. Okay, now the second derivative, you put 2 notches up here. And because it's 2 notches, you call it f double prime. All right, pretty simple, right? And we'll talk about what the second derivative is, but basically it's just taking the derivative of the first derivative. Now, if you wanted to figure out the third derivative, you would take the derivative of the second. And you would be 3 notches right here, f triple prime. We rarely take the triple derivative in terms of the real world, but I can tell you some real quickly how these relate to some problems we're going to do in the not so distant future. F prime of x can be thought of as velocity, okay, the speed of something. We've talked about that before. F double prime of x can be thought of as acceleration. Okay, of course, this is assuming the original function is position. So if the original function is position, f prime of x represents velocity. F double prime of x equals acceleration. And actually, f triple prime has a name in physics called jerk, which means basically the change in acceleration. It's when 2 acceleration forces collide. That happens in crashes and other things. So here's other ways to talk about high-order derivatives. The first derivative we can write as dy dx. Second derivative we can write as d squared y dx squared. Now, we do need to put it this way for whatever reason. When it's in terms of y, we put the 2 in between the d and the y. We don't put it over here. But for dx, we just put the squared at the end. I don't know why we do it that way, but we do. Okay, same for the third derivative. It'd be 3 would go right here, and then the in between the d and the y, but it would go at the end of dx. And this again just means third derivative. This just means second derivative. To find the second derivative, take the derivative of the first derivative. Okay. To find the third derivative, take the derivative of the derivative of the derivative. Okay, so you take the derivative of the second, basically, is what this means. To take the 53rd derivative, you take a lot of time. Okay, so we would really want to do that in the real world, right? Here we go. Let's go ahead and do example 1. We have f of x equals 5x cubed minus 3x squared plus 2. We want to find f double prime of x. So we're going to take the first derivative first, which is just involving the power rule. We should be very comfortable with that by now. We're going to end up with 15x squared minus 6x. That's going to go away. And to find the second derivative, we're just going to take the derivative of this. So we can see by the power rule, 2 is going to come down. It's going to be 30x minus 6. Let's take a look and see. All right. And again, second derivative, just the derivative of the first derivative. That's the way you would show it analytically. That's it. F double prime of x equals 30x minus 6, given that the original function was 5x cubed minus 3x squared plus 2. Take the derivative twice to find f double prime. If you have any more questions about this example, let me know.